Welcome back. In example 1.4.4, we'll be looking at this subset of the set of functions with real domain and real values. We want to know if that subset is linearly independent or linearly dependent using theorem 1.4.1. So using the number of solution of the equation which gives you 0. If possible, give a dependence relation for S. All right, so we're looking to write the 0 of this vector space, which is the 0 function. Determine the number of solutions to write the 0 function as a1 times the first function plus a2 times the second plus a3 times cos of x. All right, so this equation needs to be true for any x, for all x. Let's put it that way. It's less confusing. For all x and r. So I need to find values a1, a2, a3 for which this is true, whatever value of x I plug in. So let's try different values of x and see what we get. So this equation needs to be true at x equals 0. So at x equals 0, I get 0, a1 times 0 plus a2 times 0 plus a3 times cos of 0. Cos of 0 is 1, so I end up with a3 equals 0. All right, so for this equation to be true for all x, I need it to be true at x equals 0, and so I need this coefficient to be 0. Let's try another one. If I plug in x equals 1, I get 0 equals a1 times 1 plus a2 times 1 squared, and then the other one is 0, so plus 0. All right, so I get that a1 plus a2 should be 0. Okay, there might be different possibilities for this, so let's try a different value. Let me try minus 1. For minus 1, I will get a1 times minus 1, and I'll get a2 times minus 1 squared. a3 is still 0, so that part, the cosine disappears, which is nice because cosine would be a bit harder to deal with. So I get minus a1 plus a2 must be 0. And so I have these two equations, and if I add them, I'll get that 2a2 is 0, and so a2 is 0. And then a1, if I look at the first one, a1 is minus a2, which is minus 0, which is 0. All right, so the only way for this equation to hold for functions, so true for all x and r, would be if a1, a2, and a3, all three of them are 0. All right, so only solution is the trivial one, hence S is linearly independent. If possible, give a dependence relation. A dependence relation would require a non-zero solution, so that would only be possible if they're linearly dependent. So dependence relation, impossible. All right, but it gives you an idea of how complicated functions can be, right? You have to start plugging in values of x, and it needs to be true for all x.